A very good evening to all the viewers. I, Prachi Shrivastava, Head Corporate Relations, Sagar Group of Institutions-SISTec, Bhopal. I would like to welcome all my viewers to today's session. This is our seventh session in a row, which is under a particular theme, that is Placement Trends 2020, Hiring Patterns and Change Technology. So today we are very excited that, we are very pleased to have a guest, Mr. Amit Saluja, Senior Engineer from Google. I, along my team, Mr. Sharad, Mr. Deepak, and my student Pankaj will be joining in this session with Amit. Amit, very, very, very heartily welcome to you.
Yeah, hi Prachi. Hi Sharad, Deepak, Pankaj.
Yeah, it is entirely a pleasure that we are having you in our discussion today. And being a student to a faculty to everyone, Google is a super dream company we have ever heard about. So please tell us that how this journey begins and take up to a particular this project. Please elaborate.
Yeah, sure. So, what my current profile is in Google is a silicon engineer, and normally Google is mostly known for like its softwares, cloud, mail, and everything, right? But now, if like you would have heard that Google has ventured into making hardwares. Like few years back, it has started making its own Pixel. Then also along with it, maybe in future it would also try to make various. It has made Google Home and every other stuff, right? So previously, what used to happen is just Google would focus on search engines, cloud, and now it has started to venture in hardware. So in India, this like in Bangalore, so Google has been in Hyderabad from like maybe few years, but in Bangalore, it started its operation like a couple of years back. I when it came here, like it was just starting out, and me being from hardware profile, and as soon as I heard that okay, Google is in this like starting its own division in Bangalore and in this particular profile, I was very like excited, and I applied for it, and luckily for me, I got through, and it has been wonderful.
All right. In a span of 9 to 10 years of detailed journey of your BTech right from to this particular project, I guess this is very interesting and good that if students can hear the entire journey right from Samsung to Intel also. So could you please elaborate?
Okay. So my so my major work experience has been in electronics domain. Normally, what happens for us electronics engineer after completing our bachelor? So I did my master's also in electronics. So what happens? People generally end up doing software job, right? But I was very much focused. Okay, I want to be in a electronic space. Now there are separate streams in even electronics. If you see end-to-end of electronic system, it's like you have logic, first level of architecture, then you have logic design, then you have physical design, and then you have the manufacturing, right? So I was in early stage of my career pretty inclined towards the logic design and physical design. Eventually, I ended up being like the physical design part of it. I found it more interesting because it was more closer to the circuit level understanding, like whatever we learn, like the gates, the wires, the implementation, and everything. Right? So I just when I was working even in Samsung or in Intel, from what my learning has been like. In industry, whenever you go, it's like it's little different than what it is in academia. So what happens in academia when you have a course, right? You start from scratch. This is the basics. You learn from there. You learn first chapter, second chapter, and then you build on the knowledge. But that doesn't happen. So if you go to an industry, it's like bits and pieces of knowledge you get from, and it's mostly passed along from people to people. It's very hard for people while working to document it. So my entire focus was always like to connect the knowledge that I get from discussing with people. When you start, you hardly know anything because the things that you learn in college make you understand the nitty gritty, but the implementation part it becomes very like you have a lot of layers in understanding. So just focus on the basics and then build and connect the knowledge that you get. And that I have tried and applied for how many years I have spent. Just you get knowledge, you connect it, you have a wholesome understanding of a particular topic, and just be clear on what you are doing. Because most of the times, what happens in industry, you have tools and abstraction and a layer of wrapper written on top of it, and you don't understand what is being done inside. Just the mantra is just to understand what is happening and just build on it and connect all the knowledge you get. Yeah, so and as days passed, I learned, and obviously when I applied, I had like 6 7 rounds of interview in Google, and there I what I felt was having the clarity in concept and having the basic understanding helps you in answering. Like you should have clear understanding of what are the basics. Also, when you implement which thing is better, how it is better, how it will help. So all those things are very important. So that is like pretty much helped me in my career.
All right. If we had talk about past 9 years or 10 years of this particular journey, even I personally feel that at that particular time there were lack of platforms which can provide us the real time learnings, and for
Yeah.
today's generation it is abundant, and it is
Hmm.
in very much time they can be able to learn rocket science, engineering, and
Correct.
some or the other way. If we please to ask all their connected students or the all the viewers, those who are into computer science and electronics field, they have a lot many profiles and projects available as far as their coding practices can be frame apart. If we talk about hardware engineering or the software engineering, in both the cases, platforms will be there to help them. For example, if we
Correct.
talk about Google, Hacker platform is there, Geeks and Geeks are there. So they
Correct.
can, for all product-based companies, they can easily learn and grab all the opportunities. So time is not that challenging, which we have faced in our, previous time. So for that, could you please elaborate what all projects you are dealing with at present?
So I cannot go into the specifics of the project. I can tell you the underlying things that are there. So, but yeah, just adding on to your point, when we started, like my
Whatever is
bachelor,
very confidential, please do not intervene that.
yeah,
But
yeah,
yes, whatever
yeah, I
the fact, you can say that.
correct. Yeah. Yeah.
Right.
So yeah, sure. So just adding on to your point, there are a lot of like education material, like in Coursera, you get lectures from Stanford, Berkeley, all these things. Even for a Python, you get a very comprehensive lecture on Coursera. Then you have machine learning, artificial intelligence, everything is there, and uh, we like are fortunate at this time we have a lot of online learning, so that obviously everyone should take advantage. Even when like we are working, we also try to, when we want to get grasp of certain things, we resort to like online learning that is pretty like at your convenience, and you can use that. Projects, I would say, so my particular projects have been mostly in like processor design and uh, signal processors, ARM cores, like over the course of my career, and IBM mainframe processors. So, just to this thing, I can specify that my particular task is like a physical implementation thing, as in like when you have a logic file. From that, it's like you have an architecture like for ARM cores, right? ARM is a company which like has defined the architecture for a processor, and now most of the companies use ARM processors in their phone. Like even Snapdragon is ARM processor. Every other, like all the mobile compute is being dominated by ARM. But the thing is, ARM only makes the architecture. For from that architecture, it depends. Like Snapdragon also has ARM, and Exynos also will have ARM, but it's the implementation which separates Snapdragon from others. Like they would push the frequency, they would push the performance, they will like minimize the area and power, and that is what differentiates them. There would be little bit of tweaking, but you get the architecture and logic from a third party like ARM, and every other industry uses that. Similarly, you have a lot of IPs, like Cadence provides a lot of IP, Synopsys provides a lot of IP, and ARM obviously is the leader. So you get the architecture, and you like make it more robust in terms of, like, if you would have heard this, I guess Samsung phone had this S6 or S7 had this issue of, like, it was blasting, right? And it was banned from the airport. That was because of a bad physical implementation. It wasn't taken care. The battery part wasn't taken care. The connections were like from the circuits. It wasn't, the heating problem was there. So the power. Now when we push frequency and when we go to latest technology, it becomes a multifold problem. You have to optimize for area because you want to push more and more functionality in a same handset. So you want the similar thing to be done by a smaller chip size. And on the same hand, because you have a lot of apps running, you also use GPS and everything, you want your handheld devices to consume low power. So the power is important, the area is important, and obviously you want to push for the frequency because that is what gives you the uh, like, that's the luxury. That is what everybody wants. You want to play game, you want to open multiple apps, right? So the power, area, and performance are the base of every device that we uh, have, and mobile is a prime example. So all the, and I have worked in, like, you have this base station, like mobile base station. There is an SoC, which is the front end, because our mobile connects with the base station, then it routes. So that is a digital front end. So that I have worked in my previous companies. Then you have processors for printers, processors for mobile handsets. So and digital signal processor, graphic processing unit, and all that. So that is my primary like projects that I have done.
All right. Amit, if you don't mind, can we raise some queries? Students are keep on asking. So, two
Sure.
or three questions they have posted. Sharad,
Sure.
can you please proceed? All right. I guess the audio clarity is
Yes.
not much.
Yeah.
You're listening?
I'm able to hear, but I guess Sharad's
Okay.
screen is
Yes, I
moved.
have some. Hello, good evening, Amit.
Yeah, hi Sharad.
Hello,
Yeah,
good
Sharad,
evening,
I'm able
Amit.
to. Yeah, yeah. Good evening, Sharad.
One question from student side. Please tell us the designing and manufacturing scenario of IC chips in India.
Okay, so when you come to, like, designing, you can see, you know companies, right? There is Qualcomm, there is Samsung, there is Intel, there is Apple, there is again now Google, all these companies. There is AMD, right? A lot of companies, but the primarily based, it's based on two models. One is a fabless model, and other is with fab model. So over the last of, I can say, 10 years, a lot of companies have which had their own fab, like IBM had their own fab. They sold it for to global foundries. So their contract was, they sold it to global foundry, also gave them some additional money, and took a contract, had a contract with them for 10 years. Like, they would manufacture their chips, and IBM would in turn give them their own foundry plus some cash. So because it's very hard when you are scaling down, you have to have a entire focus on that. So IBM has shut down its foundry. Intel, for the larger part, still it has its own foundry. Intel was the technology leader, like, throughout 50 years of almost the chip implementation. But recently, like in like 5 6 years, you might have heard the news that it got stuck in its 10 nanometer. The throughput for the chips was not good, and their yield was very less. As in, if they produce 100 chips, there were like 5 to 6 chips which were, like, working in good condition. So it had very bad. So if in current scenario, see, Intel still there, it's pushing for its 7 nanometer. TSMC is there, which is being now like an Android for a smartphone. It's like TSMC is a plug and play. Like, Qualcomm uses it. Google for some projects might use it. Uh, and also like Samsung and TSMC. So these two are like foundries which are accessible to all other players, including AMD, Apple, Google, every company. They can use services from Samsung and TSMC. So the thing is, our government now has, like, is trying to push that we should also have a foundry in India. But till now, for normal manufacturing, India doesn't have any. There is a, like, fact, like, foundry in Punjab, but it's for internal like defense projects and everything. But for commercial products, we don't still have a foundry in India. So foundry is a place where, like, if you do every design, then you create a file which you give it to them and they build it. So their task is just to make it based on. So the first thing comes is like the spec, what you want the chip to do. Then comes the architecture. You design the architecture, then you write the logic for it, then you physically build it, and then after making it, you create a file, you give it to someone, and they can manufacture. So in India, there is like at present no commercial manufacturing for semiconductor chips. Designing, yes, designing. There are a lot of companies which are here. If you compare, I think maybe India's Bangalore is like maybe only second to Silicon Valley in terms of the design companies it has. It has a lot of opportunities. You have like, and I mean, I don't think any, maybe Apple is still not here. Otherwise, most of the company which is involved in chip designing is here in Bangalore. So you have a lot of options in India, in Bangalore, that you won't even have in Europe or Canada or anywhere. Maybe just the Silicon Valley might be the first, but after that it's Bangalore.
All right. Mayank, can you please elaborate the second question? Okay. Thereby, we can ask you that, this COVID era, this has, portfolioed any number of things to our youngsters' mind. Project profile is one thing, what they are learning is another thing, and actually the real implementation of these smart technologies are very different. And as far as we are taking, like, self-reliance and committed government in their production of everything, so I guess they put more pressure towards the fresher to learn all these technologies.
Correct. So the thing is, from what you see, maybe a sales profile or a retail store, those, and retail store also not for FMCG like consumable goods. It's just for others. These are the domains which are severely impacted, and also hospitality, sector, flights, commute, and all those are affected. But if you see technology sector has not actually it has not gotten affected by this COVID, because most of us, like including the IT sector, the only issue currently which was faced little by the IT sector was because the US stopped,
Yes.
like that was like Trump's policy. It's like it's
Yes, because
non-COVID related. But if
at
you
present
just
time,
consider,
yeah, at
yeah,
present time, youth is very much, audible towards the media scenario, and they get affected because they are keep listening one thing or the other way by times and very often. So their mindset towards this learning technology is, by the times you are learning all these things, it is not something like trends will be go off, because of course, for example, we're talking about all the IT sectors, whether in a service or the product domain, they are keep expanding their exploration. But on the second hand, they are asking all the engineers to learn a bit and become a more competitive, because these days, of course, the hiring pattern will shuffle, and all the recruiters will be emphasizing about the lower down their numbers as far as freshers are concerned. So this give a boom in competition. Each and every fresher engineers has to learn. It is not only talking about a one or single skill set. They have to opt for the integrated engineering also. For example, here we are talking about, later in the stage, we will confirm about the internships and everything. Again, for the computer science and the electronics branches to be catered out as far as Google is considered. So I guess, very important message to all the youngsters that they should keep an eye in the changing technologies, and they have to opt integrated engineering also. It is not something what all 30 or 40 subjects you are reading in a particular domain. It is also been by the other charismatic competency subjects which is in the another branch also, right?
yeah,
So
yes.
everybody, we will not going to hesitate to ask you this, that is this a true passage if we talk about ITs and NITs only getting the chance to get recruited by the Google or something?
Uh, I don't think, like, it might play a part in initial part of your career, like getting your first job, or uh, like Google comes on campus and hires you and all that stuff, and maybe for other companies also. But once you like gain experience, and also once you apply after gaining some experience, it's mostly based on whatever you have learned. It hardly matters that from which college you have completed your engineering. It helps in certain contexts, obviously, because it gives you a certain benefit, as in it wouldn't help in you getting hired. It can be like if somebody takes 5 interviews and they think, okay, you might not have performed well then, but your college is good, they will, okay, try for one more interview for you, and in that you have to impress. But maybe if you don't have that backing, maybe you have to do good in 5 interviews. But 5 interviews are good enough, right? It's like when you are there for your interviews, you should prepare well, and also uh, whatever you do, you have to learn and you have to grow. And see, when you work, it's mostly you have to deliver on the products and everything. So you have to meet the timelines that are your responsibility, and that is what you are getting paid for. But also for yourself, you have to keep learning. You have to understand what you are doing and how you are doing it. It's very easy to, after just starting your job, get lost in, okay, this is the things that I have to do, I'll do these things. It might be just a company specific thing, and you just become very habitual of learning those things, and then you end up spending all your time in that company without even understanding what is the normal, what is the other industries doing, what is the basics that you should know, what is the industry standard for that particular thing that you are doing. So every time so first thing, so what I am primarily talking about, once you get your first job, then you have to learn and then grow, and then obviously you can apply at all these places. The second thing is, even when you apply for your first job, even for internships, so the things that you should know are the very, very common for across, like everyone, for all the branches. Like you should be very thorough in, everybody works in Unix. You should know Unix environment. You should know the editors, Vim editors. You should know the basic scripting techniques. Like you should know the shell scripts. You should know Perl. You should know Python. You should know a certain bit about the communication protocols and everything. So the basics would help in every, even if you are of any branch, more so if you're of computer science background. But because everything you do, like even a mechanical engineer has to work through his computer only, right? He's not going to go and fix and make some things by hand. You have to use your computer, you have to use the tools that you have on hand, you have to automate things, you have to customize things. So all those things, for that, like it's like for you to do things, those are your hands, those are your tools. So you should know the basic. You should always have one or two scripting languages that you should know, regardless of whether you are from electronics, from computer science, or even from mechanical. You should know how to work on the Unix, because that is where nobody uses Windows or Mac, uh, like OS, for this work. And you should always understand the basic terminal protocols and everything.
All right. And happy to
Very
share
correct,
with
sir.
you, like, you're coming for this
Deepak.
platform. So, yeah.
Sorry to interrupt. Like I did gone through a book these days. It was a
I
novel by
guess,
Dan Brown. Hello.
Okay. Yeah.
My
Tell me, Deepak.
yeah. So it was based on artificial intelligence, and that the author this text told us that what really happens is life come in two phases mostly. The first thing is adapt a change, then second phase is learn that change, and it continue
Okay.
moves in a same loop. Again, adapt a change, learn it. As soon as you have learned that thing, again a second step will come of the changes. You have to adapt
Correct.
it again. You will have to learn it. So we have
Mm-hmm.
to keep on moving and adapting the change. Like it gave a
Correct.
very recent example that if iPhone needs to stays in a market, it needs to outperform all its competitors as soon as they bring a new skill. Just show them that we are doing best in that. Again, a new skill, we are doing best in that. So if
Correct. Correct.
person needs to improvise and needs to outstay like in a market or something and make self realizable, then he needs to learn that thing, outperform itself, again learn it and outperform, and the continuous process goes on.
Correct. Correct. That is always the case. You should have a basic infrastructure. So once you learn your first programming language, the other languages are just change of syntax. But you should have that mind of learning your first programming language, learning how to code. That's important. Then obviously every language would have their own enhancements. They would give you certain more features, but then you just have to change. You just have to learn new syntax. You have to change. You have to know the basics. So yeah, obviously you have to learn and evolve, and the jobs that you have now would be very different from jobs that you would have 10 years or 5 years down the line, because everything is changing. So but you have to keep on learning, and that happens. It's not see, if you compare from one time point to the other, you would see a huge difference. But when you go through that, right, it's not a sudden change. Nothing changes suddenly. It would be gradual for you. You have to hit the starting point now, and then along with it, you have to move till you reach a point where you could be implementing the things which you now think is very impossible. Like 5 years down the line, if somebody would tell you that you would be normally, like, you could simply use artificial intelligence for your whatever type of code you do, or whatever things you would say it's a big step. But you just have to start now, and obviously everything moves gradually, and the speed would be faster. You would reach there. So just whatever you can do now, focus on that. And obviously once you get into something, gradually you will learn and you will evolve.
All right.
Yes, sir.
So to carry forward the discussion, we have our student of pursuing BTech graduate from Computer Science branch, Mr. Pankaj Lal. He is coming up with some project, and he's very dedicated towards learnings and everything. He loves to explore the outer world, be it at any segment and integration. So he would like to elaborate this particular thing. Pankaj, please go ahead.
Thank you, ma'am. Hello, sir. Very
Hi,
excited
Pankaj.
to share the same space with you. I am Pankaj, currently pursuing my BTech in computer science. In these all
Okay.
engineering years, I had learned many languages, and I want to
Okay.
make my career in machine learning and artificial intelligence. For
Okay.
example, like I have done image recognition and also taught neural networks how to recognize handwriting. So I just want
Okay.
to ask this, um, what things I need to learn if I'm looking up to work with Google? Because as I am from private colleges, and as also you have shared, like if you have some experience and then you apply for the Google, your selection chances increases. So this is
Correct.
what I want to ask: how I can catch up with Google?
Yeah, first thing you can do is apply for an internship, and if you get that, it's a good chance. Like once you are an intern there, and if you do well there, it's like highly probable you would graduate to becoming a permanent employee. So that is the first thing. The second is like what all you should learn. You're doing pretty well now. You should. So what's the like scripting language you use? It's is it
Python,
Python? Python,
yeah,
right?
Python. And I
And
currently
you
work
have
on Ubuntu itself.
Ubuntu itself,
Ubuntu,
correct.
yeah,
Huh. So, and also you would be using any other programming languages as well, right? Like
huh.
C, Java, and all.
Exactly. I'm using C++.
Correct. So these are pretty much the things that you require. It's not only about knowing a script or knowing a particular language. It's like learning to program uh, like a medium to a slightly difficult problem. I don't think they would ask you very difficult problems up front, even if they shortlist your resume. It's like based on your college level experience, they might ask, or any other company. I wouldn't take Google as an example. Any other company, once you start your career, they would ask you a medium difficult to a slightly difficult. So it's not about just knowing the syntax of the language, knowing the how to program, what are the headers and everything. It's like creating a logic. Now you would have implemented a program which you know, but all of a sudden, if you get a program and you have not thought about that, how would you go about it? It's your approach. Most of the times I'll tell you, it's like even the syntax doesn't matter. It's about your logic. If it's like you should be able to write your algorithms for solving a problem. It's not about the language. It's like how do you create the syntax. You can error out, like you can have errors. It doesn't matter. Ideally you shouldn't, but it's fine. The main thing is like you should know how to get a job done, how to build a logic, how to make algorithms for completing a particular task, and how you approach it. Like if you get a problem statement, okay, the first thing that you do, the second, and whenever you communicate, right, always so from my experience, what I can tell you, it's like always try to engage with the person. Like, okay, this is my first thought, this is what I am thinking of doing, and Okay, I'll go about it. Okay, but I'm like stuck in this thing. Okay, so if you communicate, right, if the other person sees that, okay, you are trying and you are getting things right, he would always help you out. Ideally, he should. And that's
Means
the
logic building process.
yeah.
A
So
logic
you
building
should.
process.
Correct. So you should have a mindset of solving problems and breaking down the problems, and your approach is more important, and the logic that you have of solving a problem is more important than the syntax at last. But obviously, you should know what can be done and what cannot be done. You should not create a logic which is very hard to be implemented in a language. So that doesn't. It should be feasible, but obviously, but the important thing is your approach and your problem solving. So you should practice a lot of different problems, and I hope that would help you in like getting whatever into whatever company you wish for.
Thank you, sir.
All right.
Yeah.
And thanks for
One more
such
question from my side.
So,
yeah, please.
Uh, what type of software is used for design and analysis of IC integration?
Okay. So the thing is that I would tell, like, there are for physical design mainly, it's like you have multiple things, right? It's not just so there is synthesis where you convert the uh, logic language to gates. Okay, then you have a thing where you place those gates, then you route those gates, then you put IPs, you connect ports. So there are multiple, and then you check for all those things. Then there is a sign off tool, but the industry standard is how I would tell. So there are two major tool suppliers. Those are Cadence and Synopsys. There are other tool vendors as well, but those vendors don't have end-to-end tools to help the consumers. So for Cadence, you have Genus as the synthesis platform. Then you have Innovus, and then you have what you call it? Their sign-off tool. I haven't used that tool. It is okay. Let me get it. The other is like Synopsys, which are which is the major tool supplier. They have DC for synthesis. They have ICC2 for PNR, which is place and route, which does the placement and routing, and then they have PT for sign off. So, and then again, you have other IR checks like power heating checks. For those, you have Red Hawk. So it depends. And also, it's not just in this thing itself, you could have a separate person who just does IR. Tempus is the Cadence sign off tool. I remember. So so you could have specialization in IR drop and EM checks, electromigration checks. So you have a separate like Red Hawk there. Then you have only guys who are looking for the sign off timing. You have STA. So who would check for the cell like timing is being met, as in like the frequency is being met for the processor. It's feasible to make it. Then you also again have the design rule check, LV team, like layout verification team. So that is in itself a separate. So you have caliber there, and you can have again a synthesis. So there are a lot of domains within the physical design itself, and you have a lot of tools. So just the final DC and Genus for synthesis, Tempus and PT for sign off, ICC2 and Innovus for PNR, placement and route. Then you have Red Hawk for IR. Yeah, that's it. These are the major tool suppliers, and Caliber for sign up, Caliber and ICV for DRC checks.
Okay, yeah, we are getting a lots of questions from our viewers also.
Okay.
So I'm taking some of them. So one of our viewers is asking that which is the latest chip technology that is used in Google Pixel?
That I can't tell.
Huh?
That I can't tell. It's like they don't, even when I interviewed with them, they didn't tell me what they're using. I can't tell that. But it would be
confidentiality which Amit cannot make as of now.
Yeah.
So
Yeah.
we are not supposed to ask this on a public forum.
Yeah.
We'll get back to Amit on this.
Yeah.
So I also have a question.
Sure.
It's somewhat related. Is there any method to relate runtime and energy of a processor mathematically? I repeated, is there any method to relate runtime and energy processor mathematically?
So runtime as in what runtime? Of implementing
yes, sir,
like boot up
processor,
time or implementing
yes,
any like gaming the lag. So yeah, it's always right. So the basic principle is that there is always a trade-off. So the trade-offs are between area, power, and frequency. That is like the performance that you have. So area, power, and performance. These are the major things which you want out of a chip, and always you have to sacrifice one for the other. So the example that you took is like you want any chip processor or any chip for that matter, which
like latest processor 730G, which has been designed by it has been released in OnePlus Nord. That processor is saying that we have increased 30% gaming performance and 40% processing performance, including of 5G. So they have make a trade-off in what things, like in anything.
Yeah, so correct. So they have made it more faster. So if any so normally what we study during bachelor's is MOSFETs, right? You have MOSFET. I don't think FinFET are still being taught. FinFETs are not taught, right?
No, sir. FinFETs are not.
No. So FinFETs is the thing that is getting used for everyone. Like Intel first used it in 22 nanometer, and others catched up little later. So the FinFET is the thing that is being used. Neither the BJT transistor that we see, MOSFET also we don't use, is the FinFET for the latest technology. There are still like few places where you don't need the latest one. You can still have MOSFET, but not. There are again advancement on that silicon on insulator, and then you have biased gates, a lot of different things. But the FinFETs. So the thing is, the basic thing is you also maybe if people see if you want to have lesser delay in a certain path, that means you can. So basic funda is you have flops, and there are some combo, right? There and the crystal generates the clock. So the thing is you have to in a certain time allow this data to reach to this point from flop to flop. Now, if that has to be faster, the delays of the cells and the wires have to be lower. Now, when those things have to be lower, what things you can do? So when these are lower, that means you are pushing the performance, right? For these to be lower, you have to have, so if a smaller cell is there, it has a lesser driving strength. If the cell is larger, it has a higher driving strength. So that higher driving strength would correspond to a lesser delay, which would correspond to a faster cell. Also, there are threshold voltages, if people might be knowing. Threshold voltages is like you have certain variants of a cell. You have low threshold, high threshold, and regular threshold. So the low threshold is the fastest one, but it is also the most leakiest. So if you use those cells, it makes it faster, but it also makes it leaky. So it's always a trade-off. So if you push with bigger cell for higher driving, it increases your performance, but it pushes your area. Like the area increases also because it's bigger, it will take more power. Similarly, if you go for
sometimes it happens as CPUs and GPUs are overclocked, right? So why does company won't do that like in a stock CPU? Like Intel manufacturers like somewhat Google ARM chips and mobile chips manufacture like CPUs and GPUs both, right? So why don't they overclock those CPUs and increase the performance? Why do they give us the capability to do so?
See, there is a difference when the processors are being made and when a normal different SoC is being made. When you have an interface, there is a standard, because let's say you are making a chip which is going to interface with some other chip, and it has to be compatible all the time. So the other chip is clocking a certain frequency, giving a data at certain frequency. So you have to make your interface compatible with that. So if you miss it, so the thing is, whatever you design, the yield is what tells you how many chips are performing up to the mark. When it is getting made, there is a number which you get out of yield, so that there is testing. So the thing with the SoC and the protocols implementation is, if you hit that exact frequency, then only it's usable. Otherwise, it's not, right? Because it has to interface with others, and if you miss that, you are not able to interact with the other interfaces. But what happens with processor is, the thing is, processor is like, if you have higher frequency, it's good. If you don't have it, then there is things that you can do. It's like you have DVFS, dynamic voltage frequency scaling. You push the voltage, the same thing becomes faster and you can achieve higher frequency. So why do just throw off that chip? So you understand what is the difference between i3, i5, i7, now i9 also intelligent. So the basic difference, no, it's just everything is designed for the same spec. For same spec, the idea is to make let's say they target for 2 gig, right? They make it for 2 gig. They have everything the same, but just that there are variations. When the chip is manufactured, there are variations. The silicon can be slower. There can be a heating thing. There can be a lot of things. There are a lot of extra pessimism that we add also while making it, but you at the end don't get exact chip. So what they do is they do binning. So generation is what changes the functionality. Like for the first generation, second generation, now I guess there is 10th generation. So for 10th generation, all the features they want to add, they would make just one chip. But when it is gone to the foundry, now when it comes out of the foundry, they do binning, as in the least performing chip. The chip which is hardly meeting the spec, that requires an extra voltage for it to meet the spec, would be put into the i3 category. The chip which is meeting it moderately would be in i5. Superior would be at i7. So same task both i3, i7 can do, but for the same task i7 would require lesser power because it's inherently faster. You don't have to jack the voltage up for it to reach that performance. It is in its normal performance giving you that performance. Normal voltage, it would be giving you that performance. But for an i3, it has to push up the voltage. Therefore, it gets heated when you push its performance, right? Because you made it for that, but there are a lot of things because it's in nanometers, right? The lithography is being done. You can miss that. So machine also has a slight error. Every time it makes a polygate, it makes everything is, there are variations. Nothing is perfect. So they do binning in that context. So they have a certain reference. So therefore, when you jack up the frequency by pushing the voltage, it's not good, but it's the cheaper version for you, and you want a higher performance. Like for normal operations, i3 is fine, but for gaming and all, it wouldn't be that good because to reach that performance, it again would need its voltage to be increased, and that would screw up the heating. So there are, like, this is the binning, and therefore and overclocking is like, it's always you try to check what is the optimal, like even if you keep on increasing the voltage, what is the optimal you can reach. So that is that.
Okay.
So I want to say that
All right.
being a mechanical
Thank you so
engineer,
much for beautiful insights and trending technologies, so that our viewers get a deep knowledge and understanding what all integrated things they have to work on. So see, this is the basic difference when you put more emphasis on your minor project and you're coming out to be a very clear discussion whether technology is in trend or it is in outdated, but you have to learn and bridge this particular gap between industry and academia. So we always trust for the first factor that students have to go for learnings those skill sets which are going to be in trends these days. And happy to share that Amit has already shared a Google internship for our students, and soon I will be pushing towards my students so that they could apply. Thanks for that, Amit, and thanks for beautiful discussion. Thanks for sparing some time for us and have a detailed discussions based on electronics communication and computer science engineering. Thanks a lot, Amit.
Yeah.
Thank you, sir.
Thank you.
Thank you, sir.
Thanks
Great
a lot,
session.
Amit. Right discussion.
Yeah. Thank you.
Okay. Thanks a lot, Amit.
Yeah. Thank you. Bye bye.
Amit sir,